today we're doing Unit 4, Day 3. I do have y'all froze. Unit 4, Day 3. And we're going to start talking about the graphs of exponential functions today. All right? So first of all, an exponential function is written in the form y equals a times b to the x power. So y'all know how linear equations are basically like y equals mx plus b, right? And sometimes they will just y equals a number or y equals a number and x when the y-intercept was at the origin. Okay? So a and b are just numbers, but the x is the exponent. So that's how you know you have an exponential function if your x is in an exponent, not down low with the rest of it. Okay? That makes sense. The x is the exponent if it's an exponential function. All right? So that goes right here too. So that's the form of an exponential function. What the heck? Random things. Okay. So if the base, y'all know B is base, right? Okay, the big number on the bottom of the exponent is the base, right? So if this B term is a number greater than 1, then the exponential function is an exponential growth. And we're going to talk about exponential growth tomorrow. And the graph will be increasing. Increasing means going up, right? If something is increasing, it is going up. So if the base is bigger than 1, a number bigger than 1, then you're going to have an exponential growth. If, looky here how it's written, if your base is in between 0 and 1, now what kind of numbers are in between 0 and 1? Fractions and decimals, right? But are all fractions less than 1? No, what kind of fractions are not less than 1? Improper ones, right? Okay? We won't see mixed numbers, but we will see some impropers. So if we have improper fractions, those would be in this category. But if we have a fraction that's between 0 and 1, then the function is an exponential decay. What does decay mean? Yes, it means it goes down. So it's decreasing. That means that the graph will be going down from left to right. So increasing will be going, the graph will be going up from left to right, and decreasing means it'll be going down from left to right. Now let's just talk about it. Now, when we have linear equations, now we're going to spend a day or two talking about the difference in linears and exponentials. But when we have linear equations, they had a constant rate. They had a slope, didn't they? Right? So a line is going up by the same amount every time, right? They did the rise and the run. It was going up by the same amount every time, right? My stair steps are not looking good and straight. Okay? But when we have an exponential function, y'all, exponents raise something to a power. That means we multiply more rapidly, right? Let's just start with 2. 2 squared is 4. 4 squared is 16. There's a big jump between 2, 4, and then 16, right? 16 squared is 32. 32. No. Yeah, it just keeps going up, right? Okay. So an exponential graph is going to be kind of like low at the beginning, and it's going to shoot up really fast. Okay, that's what our exponential graphs are going to do. So lines are just slow and steady. Exponential graphs will always pass a line. Okay, they will always get steeper than a line. All right, let's talk about this funny word. I don't even want to talk about it on YouTube because it's kind of, well, it's fun. How do you think you pronounce it? Try to pronounce it.
Hard work.
Actually, the P is silent.
Well, we can find the discriminant.
When you actually put the emphasis on the first 2 letters, it's an asymptote. Oh, asymptote. Does everybody say that word? Asymptote.
Asymptote. Raise your hand if today is the first day you've heard the word asymptote. Not me. Okay. So an asymptote is a funny word. Okay? An asymptote is a line on a graph. It's pretty much an imaginary line. It's not always there. You can't see it. It's a line where the graph gets close to it. Where the graph gets close to, but never touches. Okay? So a stupid way for you to remember this, it's kind of embarrassing, you don't touch asymptotes. Okay? Okay? You might get really close to an asymptote, but you don't touch it. All right? Okay? Why is that funny?
It just is. It's how you said it.
You don't do it. But that's the truth. That's seriously what an asymptote is. Okay? It's a line that you get close to with your graph, especially exponential graphs. But your graph is never going to cross that line. It's never going to touch it. Y'all always remember what I said.
Is that even usually?
Yes, you approach it but never cross it. You approach it but never cross it. Okay.
Well, you did not get what you was made. That went
No.
over your head.
Yeah. Yeah. Some people have no self-control. All right. Y equals 2 to the x power. So we're going to graph our first exponential function. Y'all remember when we first graphed lines? Yeah. We made tables, right? All right, those are kind of a pain in the tail. All right, but those are the best way to graph an exponential function. So we're going to make an x and y table, just like we did for lines. And we're going to pick x's to go in our table. Okay, so y'all draw an x and y axis on your notes. Or x and y table. Now we're picking x's. Now x's are the exponent, right? X's are numbers we're going to plug in for the exponent. Now look at my graph, y'all. It's not very big. It goes from negative 10 to positive 10 across, right? And up and down. Okay? So I don't want to pick 5 for an x because 2 to the 5th power is 32. Y'all with me? Okay. Yeah. Just quit interrupting my class and go take care of it. All right. So, anyways, so we're picking our x's. We don't want to pick big numbers, right? We want to pick numbers as close to 0 as possible. Now, we do need to have some negative numbers on there because we need to see what's happening on both sides of the graph. All right? So, I usually pick -1, 0, 1, and 2. Now, I don't want to pick anything bigger than 2 because, like, even 3 squared is 9. And after that, it won't fit on my graph anymore. Right?
Yeah.
So we don't want to pick big numbers. So to get the y values, we're going to plug them in right here.
Oh, yeah?
Okay? We're going to take 2 and raise it to that power. So the first one is 2 to the -1 power. So remember our x's are our exponents. So what do we do with the negative exponent? We make it a fraction and move it to the denominator, right? So that's going to be 1 over 2 to the first, which is a half. Correct? Y'all with me? So that's that y value. Then then it gets easy for me. 2 to the 0 power. What does 2 to the 0 power make? 1. And then I have 2 to the first power. What's 2 to the first power make? 2. And then I have 2 squared. And what does 2 squared make? 4. So these are my y values right here. 1/2, 1, 2, 4. So I have the point -1, 1/2, 0, 1, 1, 2, and 2, 4. Y'all with me? Okay, so you're going to graph those 4 points. How do we graph a half? All right, you're going to start at the origin, go left 1 because the -1 is the x value, and then you're going to go up halfway. Okay? If I zoom my graph a little bit, it might be better. All right. And then I have the points 0, 1, which is right here on the y-axis. I'm trying to graph it, and it's not letting me. And then I have the point 1, 2. Yep, right 1 up 2. The x value. I zoomed in, sorry. And then the next ordered pair is what? 2, 4. So do you see how that's not making a straight line? Yeah, it's kind of curving. Okay? Now here's something else. It's never going to cross the x-axis because that x-axis is our asymptote. Okay? It's the asymptote. So what you're going to do when you draw your line is you're going to draw a line that's really close to that x-axis but never crosses it. And you're going to go up through your points. And I don't know what that crap keeps popping up. And you're going to put arrows on it because exponential graphs go forever just like lines do. And there's your graph. No, sometimes it goes down. And sometimes it goes from left to right down this way. It's either going to go up or it's going to come down. You'll see examples in a minute. You have a question, you stretch it. All right. So, y'all tell me, is this an exponential growth or decay? Growth, because you can see it's going up from left to right. Also, we can answer this question just by looking at the equation. That 2 is bigger than 1, isn't it? Yeah, so the beginning of our nutshell, if b is greater than 1, it's going to be a growth. All right? The domain. Now, we've talked about domains before a lot, right? Domain is talking about what values? X's. So our X's from left to right are going to hit what? Did you forget everything I taught you about domain and range? Left to right. Our X's are hitting what numbers?
Oh, yeah.
Y'all have a benchmark next week. Y'all need to start studying everything I taught you. And more than that. What do arrows mean? It goes forever.
Oh, so they're
It's -1.
greater than or equal to negative.
Nope. X's. Left to right. What numbers am I going to be hitting from left to right if I have arrows going in both directions, left to right?
All real numbers.
All real numbers. Y'all have got to remember things. We don't learn it and forget it. That's why y'all can't do fractions. Y'all learned it in 4th grade, think you didn't even have to know it anymore. Range. Range is talking about what values? Are the y values all real numbers? No, because we already said we're not crossing that x-axis, are we? So what do you think the y values are going to be doing? Greater than what? No. It's actually going to be greater than 0. Right. It goes below 1, but they're going to keep going smaller and smaller and smaller and smaller and smaller that way.
But it never passed.
But it's never going to hit, it's never going to hit below it. Okay? Now, the asymptote, let me go ahead and skip that. Skip to asymptote. It's going to be the same thing, but it's going to be y equals 0. Because that's a horizontal line, isn't it? Yeah. So your asymptote and your range go together. Does that make sense? Your range is numbers greater than 0, because the graph has to be numbers greater than 0. Your asymptote is y equals 0. It's this horizontal line. It's never going to cross that horizontal line. Does that make sense? All right, so the y-intercept is where we cross the Y-axis. And we're crossing the y-axis at what point? 1. So 0, 1. And that's what you do. You make a table. Now that's going to seem like it took forever to do that one problem because y'all can't remember domain and range, even though I just taught you 3 weeks ago. And so the rest of them should go quicker. We might have to use calculators to help us, including me. That's it. You make the table, graph your points, and then answering these questions. All right? All right. Number 2, we're making a table. X, Y. Now, what X's do we want to pick? Yes, we want to pick small X's. Okay. Now, the calculator might help us. Okay? I'm okay if you use your calculator. Now, I got to get mine. Hang on. What I don't like about this is I can't have them on the same screen, so I'm going to be flipping around a lot, and that gets on my nerves, but it's okay. All right. Use parentheses. Did that say 1/4? Yes. To do your 1 divided by 4. Okay? And then hit your rooftop button to raise it to the -1 power. Now use your little negative down there. And then hit enter, and it should be 4. Right? Because I flipped the fraction because it's -1 power. I didn't guess. I know. All right. Then the next one's easy. What's 1/4 to the 0 power going to be? 1. I don't even need my calculator for this. What's 1/4 to the first power? 1/4. And what's 1/4 squared? This one's this one's actually pointless to use your calculator because you can multiply it times itself. Now 1/16 is a lot smaller than 1/4, isn't it? Yeah. Okay. So that one you really didn't need your calculator on, but I'll let you use them if you need to. So graph my points. Left 1 up 4. Uh-oh, you see a difference here? 0, 1. 1 1/4 is teeny tiny. And 2/16 is teeny tinier than that. So do you see how your curve is going up this way but going down from left to right? I'll see that. So we still have an asymptote right here on the x-axis. So we're getting really close to that x-axis, but you're not going to cross it. So when you draw your curve, try to touch your points. But don't cross your x-axis. You can set on it if you want to, but don't cross it. Okay, so is this one an exponential growth or decay? Decay because it's going down from left to right. Y'all see that? Okay, and also this B number right here was smaller than 1, so that lets you know automatically it's supposed to be a decay. Okay? All right, domain. What are my x's doing? Yeah, from left to right, it's going to hit everything eventually, isn't it? So all real numbers. Yeah. You want a clue? All the domains are going to be all real numbers. Spoiler alert. All right. Range. Range. What are my y's doing? They're not going below the x-axis, are they? So the range is what? Y is greater than 0. So what's my asymptote? Y equals 0. Because remember, y equals a number is a horizontal line, right? No, the range will change. And my y-intercept is 0, 1. Now, yes, it's a coincidence that the range and the asymptotes have been the same in the y-intercept for these 2 problems, but those can change. Okay? Those 3 can change. But our domains are all going to be all real numbers. Y'all with me? All right, number 3, it gets harder. All right, so this one gets a little harder. We have 3 to the x power, there's our exponential part, and then minus 1. I'll say that. So we got to do the exponent and then subtract 1. We still want to pick our same x values. Trust me, you don't want to pick any bigger numbers than those. And it's going to be 3 to the x minus 1. And then that'll get us a y. I'm going to give me some space to work these out a little bit. All right, so the first one is going to be 3 to the negative 1 minus 1. So that's 1/3 minus 1, isn't it? 3 to the negative 1 is 1/3. 1/3 minus 1. Negative 2/3, right? Negative 2/3. And again, if you use your calculator, as long as you get it right, I don't really care. So 3 to the 0 minus 1. What's 3 to the 0 power? 1 minus 1 is 0. And then it gets easier to me. 3 to the first minus 1. What's 3 to the first power? 3 minus 1 is 2. And then 3 squared minus 1. What's 3 squared? 9 minus 1 is 8. So any questions about how we got those y values? Okay, then we graph them. The origin. Okay, so let me get right here. I zoomed in a little bit. So, yeah. So, negative 1, negative 2/3. So, I go left 1 and down negative 2/3, which is almost to negative 1, but not quite. And then 0, 0, of course, is the origin. And then 1, 2, right 1 up 2. And then right 2 up 8. So, this one's pretty steep. All right, so I think we're going to have an asymptote at negative 1. Y'all see that? So we just shifted down 1. Okay, there's a clue. Yes, you have a different asymptote for every graph. Every graph has its own asymptote. Not the A. Okay, here's a clue, y'all. Did y'all see my, let me highlight it. Y'all see this equation right here? Uh-huh. Uh-huh. Y'all see that minus 1? Y'all see that minus 1? Uh-huh. What's our asymptote? Clue. Ha-ha. Okay. I think so. So is this one a growth or a decay? Growth. So our domain is what? All real numbers. Now my range is my y values. Where are my y values at? Greater than negative 1. So that means my asymptote is what? Y equals negative 1. And what's my y-intercept this time? The origin, which is 0, 0. Getting easier? Yeah. That's a little time consuming, right? Doing the table, doing that. But is this part getting easier? Yeah. Good. Yeah. Hmm? I don't even know. Usually a C. Well, it's called everything can't stay the same, dear. That's how you learn, is by change. Okay, so question. Before I even make a table, is this one going to be a growth or decay? Yep, if the base is less than 1, it's going to be a decay. So before I even graph it or do a point or anything, I know that. I also can know my domain. All real numbers, right? Because I told you that's always going to be true. All right. I am going to use my calculator to help, I think, this time. So x's and y's, so I have negative 1, 0, 1, 2. So let me write down that problem on the board so I don't forget it. Because I can't keep the same screen. 1/3 to the x plus 4. Okay. So it being a decay, we know it's going to be going down from left to right somehow, right? So our numbers should be getting smaller as we go to the bigger numbers, right? Yes. Okay. So there's one thing we can check with. So I'm getting out my calculator, I'm doing parentheses, 1/3, close parentheses, raise it to the -1 power, hit enter, and then I add 4, right? So that is 7. I didn't have to punch that in, but you know. So that y value is 7. Is everybody okay with that? Okay, back to my I don't have to use my calculator for this, do I? That's going to make 1, right? 1/3 of the 0 power is 1. 1 plus 4 is 5. Good. And I really don't have to use my calculator for the next one. What's 1/3 to the first power? 1/3 plus 4, isn't that 4 and 1/3? Yeah. And mixed numbers are actually better than improper when you're graphing. Now 1/3 squared is 1/9, right? Right? 1/3 times 1/3 is 1/9. Plus 4 is 4 and 1/9.
But 4 and 1/3 is.
So when I graph them, okay, so left one up 7. It's about, let me zoom in. I can get my graphs better when I zoom. I'm sorry. Old eyes right here. So left one up 7 is stop touching stuff. Is about right there, right? 0, 5 is on the y-axis at 5. Okay. Then I have 1, 4, and 1/3. So 4 and 1/3 is about right here-ish, right? And then 4 and 1/9 is even closer to 4, but does not touch it, right? So that's kind of hard to do when you have fractions, but you're going to have a lot of fractions on these. So 1/3 and then 1/9. So this one is doing this kind of thing. So what's my asymptote? 4. Look at your equation. See that?
Until number 5.
Okay. So there's your clue about your asymptote. Okay? Got it? So my range is going to be y is what? Greater than 4. And my asymptote is y equals +4. This time, what's my y-intercept? 0, 5. Very good. Good job. All right, so that's what happens when you have a plus or a minus after your number. That shifts your asymptote. Okay? A plus or a minus after your exponent shifts your asymptote. Okay? If it's plus, it brings it up. If it's minus, it brings it down. Is that good with everybody? Okay. Well, look at number 5. Number 5 is not shifting my asymptote, but it's multiplying. Here's my exponent part, 2 to the x. So is this going to be a growth or decay? It's going to be a growth. Y'all see that? If your base is bigger than 1, it's a growth. All right? But I'm multiplying it. After I do the exponent, I'm multiplying it times 1/4. Let's see. Let's see. Yeah, depends on how big it gets. All right, so let's make our table. -1, 0, 1, 2. Okay, what's 2 to the -1 power? 1/2. So this is a 4th times a half, right? Which is 1/8. Again, if you use your calculator right there, I'm not going to scream at you, but just make sure you do the exponent and then multiply times 1/4. Okay? All right? I'm not going to use my calculator when I plug in 0, though. Right? What's 2 to the 0 power? 1. What's the 4th times 1? A 4. Okay? And then I have 2 to the first power, which is 2. What's 2 times 1/4? It is. Right? And if you don't believe me, 2 over 1 times 1 over 4 cross 1/2. Now, these are really small fractions, aren't they? Yes, but they're getting larger, aren't they? Okay. The next one, I'm just going to erase my work so it's getting jumbled. 2 squared is what? What's 4 times 1/4? 1 whole. So these are really teeny tiny. Okay? Sorry. No, because you got to see a curve. You need to see a curve, so be careful. So it's -1/1/8, which is barely above 0. 0 1/4, then exactly 1/2. Yeah, and then it's 1. So these look like a straight line, even though we know it's not supposed to, because it's going to gradually rise. It's just going to do it more slowly. So that a term being a fraction is going to make it an exponential function, but it's not going to grow as quickly. Okay? If we're multiplying times a whole number there or a number bigger than 1 there, it's going to be more steep of an exponential graph. Okay? So we did say this was a growth, didn't we? I'm trying to unzoom. It's kind of hard. So it is a growth. What's the domain? All real numbers. What about my range? Y is greater than 0, because we didn't have a plus or a minus, did we? Y'all see that pattern? Okay. And then so my asymptote is y equals 0. And back to my y-intercept, what is that? 0 1/4. Okay, and if you're not sure from your graph, go back to your table. That's where the 0 is x. Right? Yeah. So that's an exponential function, but it's not a super steep one. Does that make sense? Because that 1/4 made it a little bit flatter. Okay. Predictions, my friends. Is this our last example? Oh yeah. Predictions. Predictions. Okay, first of all, is this going to be a growth or decay? Decay, because my base is less than 1. So I'm going to go ahead and mark that. Okay. What do you think my domain's going to be? All real numbers. What do you think my asymptote's going to be? Y equals -3. So what do you think my range is going to be? Y is greater than -3? I agree. Yeah, I was just making sure I didn't have an upside down. No, I wasn't. I was just making sure. You do? Okay, well, I'll do it when I can do that from my table, right? So, yeah, if you want to go ahead and fill in all this stuff before you graph it, you can do that after you do your table. And I'm for sure going to use my calculator just to save a headache. So, I'm okay if y'all use your calculator on this. Watch over you get it. Right.
So we don't have to set them all up like the first, like the number 3. So
You have to make a table. How much work you show in your table is up to you, but get it right, okay? Does that make sense? All right. All right, so y equals 5 times 1/2 to the x power -3. I'm going to write it down so I can use my calculator and go back and forth. Now, order of operations, when I'm plugging in these exponents, that's a crooked line. I do my exponent, then multiply, then subtract, right? Order of operations, the exponent part, then multiply times 5, then subtract 3. Y'all with me? All right, so my first one, I'm going to say parentheses 1/2. Raise it to the -1, and that should be a 2, right? Right? Then I multiply times 5 and get 10, and then I subtract 3 and get what? 7. So my first y value is 7. Now, I could have done that in my head, but I'm just showing you how to use your calculator. All right? I don't like that crooked line. It's bugging me. That's a little better. And then the 0 I'm going to do in my head. This part makes 1, right? Anything to the 0 power is 1. 5 times 1 is 5. 5 minus 3 is what? 2. Right? Okay. Can y'all do the next one in your head, or do I need to show you how? All right. A half to the first power is 1. A half to the first power is a half, right? 5 times a half is 2.5, right? 2.5 minus 3 is a -1/2. Y'all agree? If you don't believe me, check the calculator. I'll check the calculator. 1/2 to the first. I shouldn't even did that. So 1/2 times 5, 2.5 minus 3 is a -1/2. Yeah. And then I plug in squared. I'll do that one in the calculator just for y'all. So 1/2 squared is a 4th. Yep. Times 5 is 1.25 minus 3 is -1.75, which is -1 3/4, right? I don't care if you do fractions or decimals, okay? That's what I got, see? Same thing. Math enter is the -7/4, which is 2 or 1 3/4. Okay. So graph those. Left one up 7. We already said this is going to decay, so it should go down from left to right. 0, 2, 1 -1/2, 2 -1/2, Miss Isabel. That's below the x-axis, isn't it? And then -1 3/4. Now this is going to keep going down, even though we don't have it going all the way down to 3. It's supposed to. We could put in another. We could put in another exponent if you wanted to show, but it's never going to cross -3. So my y-intercept is 0, +2. And you can get that from your table. Okay? So you can actually get all of this. Well, if you don't graph it, you're not completing your work. All right. So that is all my examples for today. Have fun on your practice. I'm trying to end my lesson. Go away, lesson. It's not bad.